Good morning and welcome to Pre-Algebra with Miss Betsy. Today we're going to be covering two separate topics in our lecture. First, we're going to be solving decimal equations by using multiplication and division, and you're going to see that this is very simple, very straightforward. And then we are also going to be talking about some steps that we can use if we wish to solve word problems by writing an equation. I am using as my text Pre-Algebra for Christian Schools. It's the first edition. We're going to be in section 3.8 today, beginning on page 100. You don't have to have the same text, just realize that you won't be able to track exactly with what I'm doing. So let's go ahead and pray. Got a lame joke for you, and then we'll get started. Father, I'm so grateful that you love us, and I'm so grateful for your presence in our lives. I ask today, Lord, that we would honor you in all that we would do, and that you would give us the ability to learn and to comprehend the material that we're studying today. Help us to glorify you in all that we do. In the name of Jesus, I pray. Amen. Okay, I've got several, I guess, I call them lame jokes. They're riddles, but so I guess maybe they'd be lame riddles. And I'm realizing that it is still allergy season here for me, so I'm sorry if I sneeze. First one the only one that we're going to do for this video, you have to wait till the next one for another riddle. Where do fish keep their money? Well, fish keep their money in the riverbank. So next time you are looking for that money that grows on trees, well, instead of going to your backyard to get that, you can just go down to the riverbank and take out some of the money that the fish put there. So, solving decimal equations using multiplication and division. There is like really nothing to this section because you're going to solve these types of equations with decimals just exactly the same way that you solve equations that contain whole numbers. And you've seen me do this like a whole lot. What am I doing right here? Well, this is a balance scale, or it is a seesaw, a teeter-totter, and it stays balanced. And that's what an equation is like. The balance point in the middle of the equation is the equal sign, and it says that whatever you have on the left-hand side is has the same value as what you have on the right-hand side. And you're allowed to manipulate that equation any way you want to. You can add, subtract, multiply, divide, take the square roots, raise things to the powers. But as long as you do perform the same operation on both sides of the equation. See, I'm out of balance now. Let's say with this book over here, I had added 3 pounds. Well, I'm out of balance. What do I do to get it back into balance? I put 3 pounds right back on the same side, and my equation, my seesaw, is back in balance. And that's what we're going to be doing when we are multiplying or dividing by decimal numbers. So let's look at example 1. This is on page 100. Example 1, page 100, it says solve, and my goodness, this is squeaky today, solve 1.6x is equal to 152, and then it says check the answer. And you know what I do when I get tired of a pen, don't you? I just sort of throw it away. That's looking a little bit too light for me, so hopefully this is going to work better. Solve 1.6x is equal to 152 and check the answer. So I'm just going to go ahead and write this here. 1.6x is equal to 152. What operation has been done on this variable here? Well, we have 1.6 times x. And you remember that when we're solving for the variable, we're going to use inverse operations. We have inverse operations that are multiplication and division, and we have addition and subtraction. And these are the operations that undo one another. And I've used the illustration of putting on a jacket. When you put your jacket on, it has You know, it's just hanging open. You zip it up, and that's like adding something. You unzip it, and that's like subtracting it. Inverse operations undo one another. So we've seen that in the past that if we had a decimal equation, something like this, x plus 0.32 is equal to 17.1. Well, we're seeing, what have we done to the variable here? We've added. What's the inverse of addition? Subtraction is the inverse of addition, so we are going to subtract that same amount from both sides of the equation. 0.32 is equal to 17.1 minus 0.32. We have subtracted 32 hundredths from both sides of the equation, so our equation is in balance, and then you have x is equal to whatever our solution is. 16 point, I don't know, 88? 16.78 is what value we have for x. This is exactly what we're going to be doing when we're solving decimal equations that involve multiplication and addition. I'm sorry, multiplication and division, because they are inverse operations. So if we have 1.62 times the variable, the inverse of multiplication is division. We have multiplied by 1.62. Now we're going to divide both sides of that equation by 1.62. Okay? You have to show this step. 1.62 cancels out, and you have x is equal to 152 divided by 1.6. 152 divided by 1.6. We're reviewing our decimal division here, how we divide by decimals. Going to relocate that decimal point 1 unit to the right. How many times does 16 go into 15? It can't. So 16 into 152 is probably going to be 9. 6 times 9 is 54. 5, 9, yeah, 6 times 9 is 54. 144. Now you just subtract, bring down your 0. 5 times 16 is 80. There's no remainder, so we don't have to indicate that decimal point because there's no partial, no decimal number that comes up after this. So we have our value for x of being 95. Are we done with our problem? No. We've solved the problem, but our instructions tell us to check the answer as well. How do we show our check on our homework? You write check, and then you substitute the value that you arrived at for the variable, which is 95, into the original equation, and you say, is it equal to? Is 1.6 times 95 equal to 152? Well, you don't erase your work. I just erased my work because I don't have enough room. But you're now going to show your multiplication for your check. And this is where you are practicing multiplying by decimals, making sure you know where to locate that decimal point. 6 5s are 30. We carry 3. 6 9s 54, 57. 0, 2, 5, 1. 1520. But it said it's supposed to be equal to 152. It is equal to 152 because when you multiply decimal numbers, you sum up, you add how many spaces there are with both of the factors together after the decimal point. There's only one place, and that's where you locate your decimal point in your answer. So 152 is in fact equal to 152. And that's all you're going to have to do to solve a decimal equation where the variable is being multiplied by the decimal. See, I told you that this was not going to be difficult at all. Hardest part about this chapter is just doing your multiplication by hand. If we had 0.756 is equal to 0.27 times m, how are we going to solve this? This is actually skill check number 2 on page 101. Well, doesn't matter which side the variable is on because your seesaw looks the same front to back. So you look and see what has been done to the variable. Well, it's been multiplied by 0.27. So your inverse operation to undo it, you've zipped it up by multiplying by 0.27. You're going to unzip that jacket by dividing both sides of the equation by 0.27. Then you're going to go ahead and perform your long division. You have 0.756 that you are dividing by 0.27. What you have to be careful here is making certain that you locate your decimal point correctly. You want to move it in your divisor so that you're dividing by a whole number, which means that we have to move that decimal point 2 units to the right. 1, 2. So our new location of our decimal point is going to be right there. Then you simply go ahead and perform the division. Okay, I'm looking at this. Oh, okay. This is skill check number 1. They don't want you to actually go ahead and do this long division, but if you did, this is exactly what you do. Exactly the methodology that you would use. You just know that you have multiplied by 0.27. You're going to divide by 0.27. And this right here is just a free, just happens to be the one, I can't verify my answer on the book, but this is a good example of how you would divide 756 thousandths by 27 hundredths. 27 is going to go into 75 twice. 454,216. I bet you that this is not going to work out evenly. 5, 9, 7 nines are 63. 8, maybe it is. 8 times 27, 8 times 7 is 56. 8 times 2 is 16, and 5 is 216. We have a remainder of 0. So we can say that m is equal to 2.8. How would you check that? You would plug this back into the original equation, just like this. 0.756, is that equal to 0.27 times 2.8? What do you have to do now? You're going to practice your decimal multiplication. You have our check over here. You have 0.27 times 2.8. How do you do that multiplication? When you have those decimal numbers, well, you multiply it just as though the decimal points were not there. 7 times 8 is 56. Carry 5. 16 to 1. 2 times 7 is 14. 5. You add our partial products. These are called partial products. 7, 5, 6. But I thought it was supposed to be equal to 0.756, and I have 756. Well, the reason for that is you have to locate your decimal point according to how many spaces you have, how many places you have shown in your multiplication problem. You have 1, 2, 3. So you're going to locate that decimal point just exactly like that. 0.756 is equal to 0.756. You put that 0 in the front to indicate, to make it screaming obvious to you that this number is less than 0. Okay, I didn't necessarily intend to walk through that entire second example for you where you're dividing, but I think some of you are going to be tempted to think that you've got a really confusing section here, and it's not. They're just asking you to divide or to multiply by a decimal number. So I'm going to do only one example where we are working in the opposite direction. This is example 2, and it says solve x divided by 0.45 is equal to 8, and check the answer. X divided by 0.45 is equal to 8, and check the answer. Solve and check. What has happened to the variable here? That may not look like an x. X divided by 0.45. I just said it's divided. The inverse of division is multiplication. So we're going to multiply both sides of this equation by 0.45. 0.45. Don't write it like I did. Start here and say 0.45 times x over 0.45 is equal to 8 times 0.45. I jumped around because I was using two different colors. You don't have to use two different colors. I'm just using the second color here to make it real obvious what I'm doing. 0.45 cancels, and we have x is equal to whatever this product is. 45 times 8, 5 eighths are 40, 32, 360. Where are we going to put our decimal point? We have moved our decimal point 2 units to the left, so our decimal point is going to be 2 units to the left here. So what's our solution? It's going to be 3.6. We don't need that extra 0 at the end because this is not a science class. If you choose to leave 3.60, absolutely nothing wrong with it. I'll take either of those answers. So when you get confused with problems like this, when you're checking them, either one of these is going to work. Now, how do we verify? How do we complete the second part of our problem by checking? We just substitute in. And we have 3.60 divided by 0.45. Is that equal to 8? How in the world can you have such a small number, less than 4, divided by something, have it be bigger than what you started with? Well, when you're dividing by 0.4, you're saying about how many halves? We have almost 4, about a half. So how many halves are there in, if you have 4 apples and you cut them in half, how many pieces you're going to have? You're going to have 8 pieces, aren't you? So this is an example of how you can look, what I just talked you through is an example of how you can check just by estimating, say, oh, yeah, that does look reasonable, even though maybe at first blush that didn't make any sense to me. How do we verify it though for certain? You carry out this division. 3.60 divided by 0.45 that decimal point has to be moved 2 units to the right. 1, 2. And then it is located in our quotient exactly over here. Now, 45 goes into 36 0 times. 45 times 8 had better be 360. Let's see. 8 times 5 is 40. We're going to carry 4. 4 times 8 is 32 plus 4 is 36. So yes, we have verified that our solution is correct. So it doesn't matter if you're dealing with fractions, it doesn't matter if you're dealing with whole numbers, it doesn't matter if you're dealing with decimals. When you're solving equations, all you have to be concerned about is using inverse operations, realizing that multiplication and division undo each other, addition and subtraction undo each other. We have other pairs that undo each other, but we're not talking about those just yet. And then remember that your equation starts off in balance. You have to make sure that you apply the same mathematical operation to both sides of the equation. Then it'll stay in balance and you will be able to safely arrive at a value for your variable. And then, if you're going to check to make sure that you have done your work correctly, you're going to take that value of the variable, substitute it back into your original equation, and make sure that you come up with a true statement. So that's all you're doing for section 3.8. They also have at the end, part of the way through your exercise set, it actually comes in after section C, but they're talking about problem-solving strategies and writing an equation. I want to go ahead and take a moment to go through this. We'll spend a whole lot more time dealing with solving equations, solving word problems, but let's look real quickly and see what they're telling us. Of course, quickly for me is relatively speaking. This says you can use the strategy, write an equation to solve some word problems. When you plan this strategy, follow these steps. First, pick a variable. And we call this representing the unknown. That means pick a letter to represent what you're talking about. Represent the unknown with a variable. Some people like to pick the first letter of the word they're finding for. If they're asking for distance, they'll pick D. If they're asking for price, they'll pick P. If they're asking for speed, you can say S. Doesn't matter what variable you pick, but you're going to represent it with a specific letter, what you're trying to find. Now, represent other terms, other conditions in the problem in terms of the variable. Represent other conditions, and I'll explain what that means in just a moment. Other conditions in terms of that same variable that we have selected in step 1. They talk a little, these word problems have a lot to do with cost, they have to do with speed, they have to do with time, they have to do with age. For example, let's say that we're talking about my sister-in-law. My sister-in-law is 21 years older than I am. So if you don't know what my age is, we're going to say, let X be Ms. Betsy's age. Okay, I think I'm actually coming up with a problem here. And if my sister-in-law is 21 years older than I am, however old I am, which is X, plus the 21 years older that Margaret is than I am, that's going to be Margaret's age, my sister-in-law's age. Now, if we want to figure out how old we both are, Well, then all I have to do is say that Betsy's age and Margaret's age, when you add them together, what is our age when you add them together? 74. So you would say Betsy's age, Miss Betsy's age, plus her sister-in-law's age is equal to 74. And what I've done here, this is step 1. I have represented the unknown with a variable. We're trying to figure out my age. This is represented with a variable. I could have put a, but I like to use x's and y's. Step 2 says represent other conditions in terms of that same variable. So this is what I've done here. I've said my sister-in-law is 21 years older than I am, so I'm going to take that variable, which, since you don't know yet, some of you do, but you don't know how old I am, I'm going to take my age, which is x, plus 21, and that's going to be Margaret's age. And then the next step is identify what is equal in the problem. Well, the problem said that we haven't even read, you can't even read in your book, this is what I'm just creating right now. What I said was equal is my age plus my sister-in-law's age is 74. In other words, if you sum together, you take my age and add it to her age, it equals 74. And then step 4 says write and solve an equation. What's an equation? An equation is a mathematical statement that includes a verb. It includes this equal sign here. This says my age plus Margaret's age is equal to 74. We've come up with an equation. And we did that by saying, okay, this is equal. You know, this is this thing over here on the one side of my equation, on the one side of my, whatever this thing is that I'm trying to do, one side of the seesaw is my age and Margaret's age, and on the other side is 74. So we've got something equal. We can set up the equation. Now, what are we going to do? We collect like terms. This would be all that they'd be asking you right now. But we're going to add the x's together. I have 2x plus 21 is equal to 74. Oh, interesting. My age and Margaret's age. You know what? I think I have picked her age wrong. Let me think. 35, 46. Okay, right now at this time of the year, I think maybe she's 20 years older than I am. Okay, have to change that. Okay, it's going to be interesting to see if I come up with the right age. 2x plus 20 minus 20 is equal to 74 minus 20. Okay, you subtract 20 from both sides of the equation. 2x is equal to, oh how funny, 52. Going to divide both sides of this equation by 2, and interestingly enough, this says that I am, what, 36, 26? Ha! Do you think that I'm 26 here? No, I'm not 26 here, which means that I set something up wrong. My age plus Margaret's age is equal to 74. Okay, you know what the problem is here? Margaret right now is 74. This is what happens when I try and create a somewhat involved problem. Because, you know, and just in case you wondered, I'm really not 26. I have a son who's 30-some. So I set up my equation incorrectly. Let me backtrack here. See, now I'm curious. Okay, Margaret is 74 now, 52. Together, our age is 126. So let's go ahead and fix this. My age plus Margaret's age is 126. What we solved just then was some random problem with a Betsy and a Margaret who, when you added their ages together, it equaled 74. Margaret's age and my age equal together to be 126. Now we have 2x plus 20 is equal to 126. We have to subtract both sides, have to subtract the 20 from both sides of the equation, and that gives us 2x is equal to 106. We now divide both sides of this equation by 2. We have x is equal to 53, which is how old I am. X plus 20 is equal to 73, which is how old Margaret is for another month. So this is my age, this is Margaret's age, and this is an example of how you would represent an unknown with the variable. You'd identify other conditions in terms of that same variable. You would identify what is equal, and in my case we did two problems here. The first problem was where two people's ages added together to be 74. Here we corrected it, came up with another problem where it's not just two random people, but it's my age and my sister-in-law's age sums together to be 126, and you didn't know when we began, most of you, that I'm 53, but you know that I'm 53 now because we took an algebra equation and solved it. So if you're still with me, kids from pre-algebra, moms from pre-algebra, this is a more involved problem than you're going to be working on for a while, but this is very, very much an example of a real-life word problem that you can use with pre-algebra. And I think I will say that that would be the end of this video, and I'll see you next time.